Today we'll discuss Chapter 10, A Biography of the Earth. Now that we understand geologic time and how we measure it through relative and absolute dating methods, we can begin to tell the story of Earth's history. So this chapter goes through the entire evolution of Earth from its formation to its present. The Hadean Eon was from 4.54 to 4.0 billion years ago. And in its beginning, the Earth accumulated from smaller planetesimals. But as the eon progressed, Earth's interior differentiated into a core and mantle as heavier iron sank towards its center. At about 4.53 GA, or billion years ago, very soon after the planetesimals started to coalesce, Earth collided with another protoplanet that led to the formation of the Moon. Earth's original surface was likely molten rock for millions of years before it cooled into a solid crust. And the outgassing of volatile or gassy elements from volcanic vents on Earth's surface formed Earth's first atmosphere. The pictures below are two artistic representations of what the artists think that Earth may have looked like during the Hadean. The Archean eon lasted from 4.0 to 2.5 billion years ago and consisted of several important events that helped define Earth's evolution. These include the late heavy bombardment, the formation of Earth's oceans, atmospheric CO2 dissolving into oceans, a primarily nitrogen atmosphere, the beginning of plate tectonics, the appearance of continental crust, and the appearance of early life. The late heavy bombardment may have pulverized and remelted Earth's crust between 4.0 and 3.9 billion years ago. There are very few rocks that exist on Earth today that remain from this period and older. In the Archean, convergent boundaries and hotspots built small blocks of relatively buoyant crust. Rifting of these blocks may have produced flood basalts, and erosion of the blocks produced sediment. If you'd like, I encourage you to watch this YouTube video titled Archean Cratons Tell the Story that tells you a little bit about the formation of continental crust in the Archean eon, with a case study from Wyoming. In the Archean, buoyant blocks of continental crust collided and were sutured together, forming protocontinents, which were then intruded by granite. Eventually, regions of this crust cooled, stabilized, and became continents. Over time, the area covered by continental crust increased, with most continental crust forming by 2.5 billion years ago at the end of the Archean. Early life also appeared in the Archean, but around 3.5 billion years ago, shapes similar to cells appeared in rocks, seen at the top. And at 3.2 billion year old, the oldest undisputed fossils, known as stromatolites, which are mats of cyanobacteria that grow in tidal flats, first appeared. And these are present in the middle and bottom pictures. The Proterozoic eon lasted from 2.5 billion years ago to 541 million years ago. And if you're curious about etymology, the name Proterozoic means before animals. In the Proterozoic occurred the Great Oxygenation Event, the deposition of banded iron formation type rocks, formation of large continents or supercontinents, the development of eukaryotes, and also a period called Snowball Earth. The Great Oxygenation Event was a period on Earth's history where atmospheric oxygen levels increased dramatically, and the oceans became saturated with oxygen and precipitated iron oxide. This produced these rocks called banded iron formations, which are most prevalent between 2.4 and 1.8 billion years ago. The supercontinent Rodinia formed about 1 billion years ago and lasted until about 700 million years ago. Pannotia is another large continent or supercontinent and was thought to have formed around 570 million years ago, but didn't last very long. In the Proterozoic, as a result of an oxygenated atmosphere, we had the growth of photosynthetic organisms, which in turn increased oxygen more. This resulted in the development of more complex eukaryotic life forms. Snowball Earth was a period in the end of the Proterozoic where we had a cooling of the climate, forming large ice sheets, potentially that covered the entire surface of Earth. The evidence for this exists in glacial till found at regions that were at low elevations and near the equator, which indicate the extent of ice cover. Carbon dioxide from volcanoes would eventually have warmed the atmosphere and melted this ice cover, resulting in the end of Snowball Earth.